I just need your active participation and uh, again, just a heads up. If you attend all the classes that would be conducted online or face to face, then I could assure you that you're gonna be passing this course. So before we start, I just wanna introduce myself first. But the formal introduction would be on our face to face class. So by the way, again, good morning, engineers. I am Engineer Mark Jolo I'm Engineer Mark Jolo Mendoza. I am 23, and I just graduated last June 2024, and I was part of the Endure 141 who recently passed the board examination last August 2024. So uh, for the formal introduction, I would do that one when we have our face-to-face class come Friday. So I just also want to ask, uh, have you ever had your professor before me, or or is someone already handled ME 414 from the past weeks?
Si Sir Barreto po, sir.
And may I know what topics did he already discuss with you, or does he ever or did he ever start doing the classes or doing some lectures with you before?
Yes po, sir. Yung chapter 1 and 2 po. Pero hindi po siya natapos mag-discuss sa chapter 2 po.
And those topics are about friction, am I right?
Yes po.
Yes po.
Friction and engine oils is but did he discuss as well the calculations of those? Not yet.
Hindi pa
D-
po, sir.
Not yet
Hindi
po.
pa po.
And uh acknowledge engineer Esplana. So but did he discuss with you the syllabus that we're gonna be using on this course ME 414? Did he did he discuss the syllabus?
Parang hapyaw lang sir, gano'n.
Okay, so to our engineer El Shahat, am I speaking too fast?
Sir, it's okay.
Okay, good. So uh just also to give you another sight of our syllabus that we're going to be using on our classes. So I'm going to be presenting my screen. Kindly let me know if you can already see my screen.
Kita na
Okay
po.
na.
Yes sir.
Okay. So again, our course is about ME 414 ME Elective 1, which will basically tackle more about bearings, lubrications, tribology, and most of which I am not so familiar with foreign students if they are going to be taking the board examination as well. But here in the Philippines, but for the other engineers here, I just want to let you know that these topics that we're going to be discussing will all be included on the machine design part of the examination. Maybe you are going to be taking that one on maybe 2 years from now. So I just wish, I just hope that you are going to be retaining some information from our discussion so that it would be quite easier for you to understand machine design. So again, the first topic, and this would be our discussion for today, it's about the fundamentals of friction and wear. Then topic two is about lubricants and engine oil. Then third is the elements of bearing lubrication and design. And the fourth topic, it would be this is still subject for approval, but I just proposed that it's going to be the design and performance variables of bearing. Then main topic five would be this, the engine lubrication systems. And topic six would be engine friction and modeling. So basically, what I'm gonna be doing is since we're already behind by 5 weeks, what I'll be doing is today I'm gonna be discussing the first topic, the fundamentals of friction and wear. Also, I will also give you some examples of this calculations, but these are some just sort of a review for you since this has already been discussed uh, during your previous years in statics and in dynamics. So uh, this is just a quick discussion with you. It's just that it would be taking more time because we are going to be also discussing some elements or some terminologies regarding friction and wear. And next week on our face-to-face classes, I would be discussing with you the calculations related to the properties of engine oils. We are going to be having calculations there, and the calculations for the design of bearing. That would be on topic three, both of which are going to be discussed next week on our face-to-face classes. That is again that would be for the calculations of these topics. And then by week seven, it's gonna be a discussion as well. But that time it would be the discussion proper for the terminologies and elements of topics two and three. So by week eight, there we would be having a quiz regarding the terms and elements that's going to be discussed from topics one to three. Then also, the board works. Since every topic we will be having a board work, uh, you would like for example later later today I'm going to be giving you the board work one, and you are going to be submitting that one next week on our face-to-face class. And on next week, I will also be giving you the board works two and three after our discussion on the calculations as well on topics two and three. So I'm gonna be giving you the board works after our discussion. Then you are gonna be passing that one when we have our next face-to-face class. That would be on week eight. And again, on week eight, we the first hour would be a quiz uh, regarding the terms and elements of that we're going to be discussing on topics one to three. And the next hour, the second hour, would be the discussion. I would be discussing with you the calculations for the topics two and three, or for the board works two and three. And after that one, the midterm examination, then the next topics we would I would still be consulting this with the department so that it would be better if we could meet halfway on how we are going to be tackling these topics as well. So uh hold on. So by the way, do you have any questions? Am I speaking too fast? Do you have any questions regarding our schedule?
Wala naman po.
Wala naman po, sir.
Okay, so yeah, basically, since I'm gonna be also telling you that since I was first year, my block section is '07 as well. So yeah, it's kinda it's giving me an auto pass. So yeah, I that's since I have been with block '07, so I it would be like an not saying an advantage, but it's just like more of a sentimental one. So yeah, you could expect you could expect yeah. I'm not saying anything right now. For now, sorry. I'm not saying anything for now, but yeah, you can kind of expect since yeah, I have been in this section for four yeah 4 years. So yeah, let's start our discussion. I'm gonna be presenting the presentation. Hold on for a moment. Can you see my screen now? Am I presenting now?
Yes po, sir. Kita na po.
Okay, thank you. So, again, our first topic would be the fundamentals of friction and wear. I am not quite sure if you are already familiar or if we have the same material as with Sir Barreto. So, but still, if this is I am sure that you're already familiar with this. So, I'm not going to be focusing more regarding the term since you have mentioned that you have already discussed this one. So let's just have a quick uh, overview of this. So first, the history of tribology. It comes from the Greek word tribos, which means rubbing, and this is defined as the science on and technology of interacting surfaces in relative motion. So basically, tribology revolves around lubrication because uh, lubrication tends to ease the surface or the interacting surfaces of different machine parts or machine elements. So like what has been presented here, it focuses also as well in friction wear, since again we are talking about interacting surfaces or those surfaces that have contact with each other. So we are gonna be discussing or giving focus regarding that thing. So here, I am just gonna give you some quite hints as well. You you could or sorry, you need to remember at least five persons that are gonna be discussed here in the history, so that you can easily have points on the midterm examination. Just take note of that. So yeah, for the history, we are all familiar that early humans, they were rubbing sticks together, and with that, they could create fire. And then around 3500 BC, they uh, they discovered or the wheel was invented because they have learned that rolling motion required less effort than sliding because there is a lesser surface that is in contact with another surface. The reason why rolling required less effort than sliding. It's easier, it's easier to move or to create motion through rolling ra- uh, rather than sliding. The next, in 1495, Leonardo formulated the two basic laws of friction, wherein it is independent of contact area and proportional to load. But during that time, he was not credited for his work since he did not publish any of his observations until such time that Julami Amontons rediscovered this laws. So, according to him, friction was primarily the result of work done to lift one surface over the roughness of the other, thus resulting in deformation and wear of the surfaces. And Isaac Newton uh, added that moving friction was not dependent on speed or velocity, thus formulating the third law of friction. So, and all of this remained in the macro scale. Then in 1950, Philip Bowden and David Tabor gave a physical explanation for the observed laws of friction. Here, it was found out that the area of contact is a very small percentage of the apparent area. So there comes this finding that as the normal force increases, more asperities come into contact and the average area of each asperity contact grows. This becomes the foundation of the formula of friction that we are using today. Uh, is anyone from the section? Does anyone know the formula of friction? This has already been discussed with you. So, anyone, what's the formula for friction that we commonly use for the frictional force? Anyone? Yes, engineer.
Sir, coefficient of friction times normal force po.
Yeah, that's right. Thank you. So it's the frictional force F is equal to the coefficient of friction times the normal force. Like again, like what is said or what has been found out by Bowden and Tabor, when we increase the normal force, uh, the frictional force would also increase. And with this, for the analysis, when we try to analyze the forces, normal force is always perpendicular to the surface. Uh, from the contact surface. Like for example, our surface is just a horizontal or is a horizontal surface, then the normal force would always be perpendicular to it. This is going to be the normal force. But if it's an inclined surface, then the normal force would still be perpendicular to the surface. So here, is it clear? Thank you. And next, as our ability to analyze surface contacts, uh, at the monomolecular level, we learned that the macro laws don't necessarily hold and that the process of interaction are quite complex. And in 1883, the elucidation of hydrodynamic lubrication began in England with testing done by Beauchamp Tower. So this, we are gonna be tackling more about hydrodynamic and hydrostatic lubrication after our midterm examination. Your and I just want to also give you a heads up, even though even though the formulas that we're going to be using in calculating or in designing lubrication systems are quite long. I could tell you also that uh, it is quite easy as well because you are just going to be doing uh, a simple substitution, or if you already established the given parameters, you could easily solve, or you could easily design the lubrication system. And lastly, in his final phase of research, he drilled an oil feed hole in the bearing. The oil was found to rise upwards in the feed hole and leak over the top of the bearing cap. He then installed a pressure gauge and found it to be inadequate for measuring the high pressure levels. This result proved the existence of a fluid film that could carry significant loads, and this would be discussed mostly. This ideology would for the calculation of this would be discussed on lesson 2, which would be next week. Then in 1886, Osborne Reynolds published a differential equation describing the pressure buildup of the oil and the narrow converging gap between journal bearing surfaces. It was so complex that many years passed before it was solved for journal bearings. And then Richard Strebeck published the Strebeck curve, a plot of friction as it relates to viscosity, speed, and load. And after the work of Tower and Reynolds, as Arnold Sommerfeld refined the work into a formal theory of hydrodynamic lubrication. So we are going to be discussing this, the Sommerfeld number, the Strebeck curve, and the Reynolds number on topic 4 in determining the design parameters or the performance variables of bearings. So yeah, hold on for a moment. So next, that's the history. That's quite, or that is some of the notable uh, findings uh, regarding tribology. So next, we are going to be discussing friction, and I I am confident that you already know the idea of friction, which is the force that hinders or resists the relative motion of two contacting bodies. So basically, a friction occurs when there are two surfaces that are in contact with each other. So unless stated otherwise, that the surface is of smooth surface and there's no friction uh, on the surfaces. But in real life applications, there is no such thing as a frictionless surface. But for the analysis, for the calculations, some problems state that to neglect friction and assume that the surfaces are smooth. So it originates from complex molecular and mechanical interactions between contacting surfaces. So friction causes wear and generates heat, which can lead to premature failure of the functioning implants. So yeah, friction causes wear because when two objects or when two surfaces become in contact with each other and slide past with each other, then there would be some materials that are gonna be lost or that are gonna be that are gonna be lost since uh both surfaces are or both surfaces do have friction. So it really causes wear. And for also when these are when we're talking about machine elements or machine parts, if if those two two or more machine parts are in contact with each other, like for example bearing and shaft, and the bearing keeps or the bearing is rotate or sorry the shaft is being guided by the bearing, there would be a friction. There would be friction, so lubrication, proper lubrication is needed so that the friction would be lessened, and the friction would be lessened, and how do you say this? And the life of the machine parts would be longer, it would last longer. The reason why we need to have proper design of lubrication, and as well proper design of each machine parts and elements. So, like what has been stated by one of our masters here, uh, friction is represented. Hold on. Now, friction is commonly represented by the coefficient of friction assigned as mu. So, the coefficient of friction uh, is a unitless ratio. So, we're here with our stated equation. F represents the frictional force, and then it is equal to the coefficient of static friction times the normal load or the normal force N, or here it is assigned as P. So it just depends. This one and this one are the same. It just depends on how you assign variables to the parameters given. But basically, uh, we commonly use N since it is a normal force. So we assign normal force usually as N, and letter P usually is assigned to applied force. But again, it really depends. It just depends on how you assign variables to the parameters. As long as you state that one on your assumptions or on your uh, yeah, on your analysis, then it would be good. So next is we're going to be discussing about static friction. It is the friction present between two or more objects that are not moving with respect to each other. Basically, it says static. It means an object is at rest, or it is not moving relative to each other. So since it is not yet moving, since it is not still in motion, then it would require a greater force. It would also require a greater force to move the object. It would require a greater force to move the object, and also uh, the static friction or the magnitude of the static friction is greater due to the greater value of its coefficient. So again, it it just means that when it is uh, stationary, then if you want to move that stationary object, you would need to exert a greater force because of a higher static friction as well there. So the equation to represent that one is given by the static force equals its coefficient times the normal force. Whereas for the kinetic friction, opposite of the static friction, it is the friction present between two or more objects that are already in motion. So these are you could see the analysis of this. You could see this on some problems. For example, uh, an object is already moving, and there is a given coefficient of friction of the surface, and you would want to accelerate or decelerate the object. It would include kinetic friction on your calculations. And since the object uh, you are analyzing is already in motion, then this means it would only require a lesser force to continue moving this, since again since it's already moving. So the coefficient or the magnitude of the kinetic friction is also less. It's also less than compared to the static friction, and it's still the same. But for the equation for the analysis of uh, kinetic friction is the kinetic friction is equal to here the its coefficient times the normal force. Other examples are rolling friction. From the word itself, rolling, it rolls on the surface, and this friction occurs between the surface in contact with the rolling object and the surface. So it's, it's like also stated here, its coefficient is dependent on the radius of the rolling object, the depth to which the object can sink, and the toughness of the surface. So its formula is still the same. It's just that it is expressed uh, through uh, the rolling friction. So it's rolling friction is equal to the coefficient times the normal force. And lastly, the sliding friction, it takes place when two surfaces are rubbed against each other. So also from the word itself, self sliding, so it means two objects are sliding past each other. So one common example of this are those elements or those machine parts that has uh, that has shearing stress, wherein for example one plate, this plate and this plate, they are sliding past each other. This is there would be this sliding friction, and there would also be a shear stress present here. So the equation for the sliding friction as well is sliding friction is equal to the coefficient of friction, the sliding friction times coefficient of the sliding friction times the normal force. So where I know you're already familiar with this, uh, it is a solid or it is a process removal of material from one or both two solid surfaces in solid state contact, occurring when these two solid surfaces are in sliding or rolling motion together. So it is the progressive damage involving material loss, which occurs on the surface of a component as a result of its motion relative to the adjacent working parts. So again, you are already familiar with where it occurs when there is or when there are two contacting surfaces that are sliding, rolling past each other. Sorry, rolling or sliding past each other. And you could see this. One great example of this is when you are sanding using a sandpaper. That is a rough surface. And for example, you are sanding a wood or a plywood. You could see that one. It creates a smoother surface, but there is a material loss present there because uh the surface has or it is becoming worn out. And also great examples of which are uh the sprocket and chain and sprocket, and as well bearing and shaft. those uh those it occurs or during the process, it would create wear since shaft is rotating and being guided by the bearing. They have this contacting surfaces, so it would create wear, and if not designed properly, it could cause to failure of the members of the material or of the members or of the machine parts. And an example or one type of wear is abrasive wear. So it involves abrasion, wherein it occurs when a harder material is rubbing against a soft material. Then Next is the erosive wear, wherein it is the impingement of solid particles or small drops of liquid or gas on a solid surface that cause wear. One great example of this is, for example, you are gonna be dropping, you are gonna be dropping a hard stone or a rough stone on a smooth table surface. So when it gets dropped, you could see there is a deformation on the surface of the table, and that occurs, or uh, the surface of the table happens to have wear already. And also an example of which is when you drop a hot substance on a styrofoam, you could see that this part where this part where the hot material is being dropped to the surface. It gets eroded. It 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 quite dissolves the part where the hot material is being poured into. And next is the frictional wear or the adhesive wear. Again, from the word itself, adhesive, there is an adhesion where it means there would be a transfer of material, like what you can see on this. When they slide past each other or pressed into each other, then it would cause a material transfer. Uh, most of which also happen is that they combine. There would be a part where these two surfaces combine with each other, or yeah, they combine with each other when they get slided past or pressed into each other. So yeah, that's it. Uh, According to Confucius, the gem cannot be polished without friction, nor man without trials. So yeah, those were the terms and ideas regarding friction and wear. Do you have any questions regarding those? Is it too fast? Do you have any questions regarding those?
None.
How about the others?
Wala naman po, sir.
Okay, so if that's the case, then I'm gonna be presenting you some of the sample problems involving friction, and I just want you to understand this one, since this would also be part of your midterm examination. So you need to really master and understand the idea of friction. So here, sample problem one. A 400-pound block is resting on a rough horizontal surface for which the coefficient of friction is zero point 0.4. Determine the force P required to cause motion to impede if applied to the block horizontally or downward at 30 with the horizontal. So for the analysis of this, uh, like what you are doing previous with your previous uh, courses, uh, we need first to establish we need first to establish the given parameters, or the given parameters on the problem. So here, on our problem, the given is mass, or let's just assume that let's just assume that the given is already the weight of the weight of the block given is 400 pounds force. This is 400-pound force. And the coefficient of friction is 0 0.4. So yeah, that's it. That's our given. And then the next thing would be we need to find what is required on our problem. So letter A, it is the applied force. Applied force. P, horizontally. And letter B, applied force. Based on the problem, again, it's letter P, assigned as P, downward at 30 degrees with the horizontal. So next would be we are gonna be uh, doing the diagram. So hold on. Let me just erase this. So basically, that would be the process of answering your board works. So first is the given, then required, then diagram. So let's just assume that this is already our diagram A and diagram B. So for the analysis, since it is the block is resting on a horizontal surface, so its weight would be going downward. And if base here, the force P is applied to the right, then the frictional force that would resist this force would be going to the left. Would be going to the left. And again, like what I have mentioned, there would always be this normal force that is perpendicular to the surface. So here, it's the normal force is perpendicular to the surface going to the right. And from this, I would suggest or I would accept as well if your whole diagram here would be on a Cartesian plane like this, letter A. So you would draw this going upward is the normal force and going right is your applied force P and going down is your weight and frictional force is going to the left. So by doing this, you could easily analyze the component forces present on the x and y axis. It would be easier to analyze this. And for letter B, the same goes with letter A. It's just that the applied force is 30 degrees downward with the horizontal. So if you create the Cartesian plane of letter B, it would be the weights going down. Uh, the frictional force is still going to the left. The normal force would be going upward, and the force P, like what is stated, it is 30 degrees with the horizontal. So it's going. This is the horizontal, and it's going to the right. And it says 30 degrees with the horizontal. So this is the horizontal. 30 degrees would be this one. 30 degrees. So this would be your the analysis of or the diagram for this. Now, after establishing this, we could answer or we could start solving for our applied force. So for letter A, uh, based from our diagram, it would be easier to start with the summation of forces in the vertical component. So the summation of forces in of y equals 0, wherein upward is positive and downward is negative. So upward would be the normal force and downward is the weight. So basically our normal force is equal to weight, which is equal to 400 pounds. Next is the summation of forces y, sorry, at x component or the horizontal component based from our diagram. Positive is going to the right and negative is otherwise. So positive is the applied force P and the frictional force is negative equals 0. So P equals F, which is the frictional force is again equal to the static friction of coefficient times the normal force. So our static friction given is the coefficient of friction is 0.4 times 400 pound. So what is our applied force? Anyone? What is our applied force?
160 po, sir.
Thank you. So that's it. As applied force, applied horizontally to impend the motion, it's 160 pounds. So this is your final answer. For letter B, we're going to be doing the same, analyzing the forces on each on each components. So again, forces in y equals 0. So going upward is the normal force. Then going downward is the weight. And as you can, sorry, and as you can see on the diagram, let's just redraw it here. Uh, 30 degrees, normal force, weight. Sorry, and this is the friction. As you can see, the applied force P. The applied force P is does have or it has an x and y component here. So if we could see the triangle, uh, 30 degrees, then this is x component, this is y component, this is your applied force P. So basically, since we're analyzing the x component of this, we need, or sorry, the y component, so we need this. And this is opposite of the angle. So our y component is sine 30, since opposite, so sine over hypotenuse, or sorry, opposite over hypotenuse. So y over p. So y is equal to the applied force times sine 30. So since it's going down, it's negative p sine 30. So getting the normal force, we have normal force equals W weight plus p sine 30, which is equivalent to 400 plus p sine 30. So we still have two unknown variables here, the normal force and the applied force. So we still need another equation. If there are two unknowns, we still need to create, or we still need to find another relationship by doing another equation, or by having another equation. So we need to have the summation of forces x as well, wherein again, going to the right is positive and left is negative. So from the or for the applied force P here, uh, the x component, it is adjacent to the angle. So we are going to be using cosine 30 equals adjacent over hypotenuse. So x is P cosine 30. So it's going to the right, so it's positive. P cosine 30 Negative is the friction equals 0. Then P cosine 30 equals F, and P cosine 30 equals uh, the friction is static friction times the normal force. And from here, from our equation 1, normal force is 400 plus P sine 30. So we can just substitute it. P cosine 30 equals 0.4, 400 plus P sine 30. And from here, you could see that we only have one unknown variable, which is uh, the which are or which is the one we are required to find. That is the applied force. So we can just do this on our calculator. Just type this one and uh, do the shift solve. So we could find the applied force P, which is equal to anyone? What's the answer?
Sir, 240.23 10769 po.
Sorry. Again, 240.
240 40 po. 40.
Point.
231 0769.
Thank you. So yeah, that's it. Uh, so the applied force needed to impede the motion if it's applied 30 degrees downward with the horizontal is 240 uh, pounds. And when you do your board works, uh, kindly do not round off nor truncate your answers. When you box your final answer, you always have to not round it off. Okay, just copy what is presented, or what you just solve on your calculator. Just copy everything, all the figures on your calculator. It's just that on our discussion here, I'm gonna be truncating the numbers just for the sake of this discussion. So is this clear, or do you have any questions with this? Yes, Engineer Atienza.
Sir, halimbawa po, ta's mahaba po yung decimal, puwede pong ang isulat na lang po namin halimbawa hanggang 4 decimal po, pero 'pag sa pagko-compute po namin complete ano naman po, naka-shift star po.
What you mean is that you are gonna be just boxing the final answer in four decimal places. Am I right?
Hindi po sir, halimbawa po hindi pa po tapos yung ano, yung hinihinging sagot po. Tapos may mga process po na dumaan po na may mahahabang decimal. Tas yung pong anong yun, yung value na yun shinip-store po namin. Tapos gagamitin pa po sa sunod na computation. Puwede pong dun sa sunod na computation po isulat na lang po namin, ano, hanggang 4 decimal po or isusulat po namin lahat ng decimal na yun.
Uh, okay, I get it. You, I would allow just on my class. Uh, do not do this on other courses. For example, for example, you found or you found the normal force n, and for example the value is 100.278273654. You could just assign, for example, you store it uh letter A, you store it to A on your calculator. You could just put, I would allow it, you could just put A beside that normal force, then circle it. Then when you use that one on the next calculation, you could just, for example, here on getting the static friction, it's equal to the coefficient of friction times the normal force. You could just, I would allow you to use for example, that's the static friction is zero point 0.4 times A since you store that value on letter A. Did you get it?
Yes po, sir. Thank you po.
Yes. Yeah, but then again, that is only allowed on my class. Okay, you will you do not need, you should not do that on your other classes, especially on other design and calculation subjects. Yes, engineer. Engineer De Castro, I think you have, or
Napindot,
yes?
napindot lang po.
Okay. So do you have any still, or do you still have any questions regarding this?
Po, sir.
Okay, so last problem. So here is your calculation solution. So here, a block of mass m, which is 10 kilograms, is sitting on a surface inclined at an angle 45 degrees, given that the coefficient of static friction is zero point 0.5 between the block and the surface. What is the minimum force necessary to prevent slipping? And what is the maximum force F that can be exerted without causing the block to slip? So again, uh, for the analysis of this, uh, we need to establish the given parameters first. Given it's the mass m, capital M, 10 kilograms, the angle of inclination of 45 degrees, then the static of friction is zero point 0.5. Then we are required to find letter A is the maximum for, or letter A is the minimum force, sorry. It's the minimum force, F, and then, or let's assign this as F min. Then for letter B, maximum force, we are required to find the maximum force to prevent sleeping. So yeah, the next is we need to draw the diagram. So for hold on for a moment. Yeah, for letter A, let's look at the presented figure. For letter A, we are asked to find the minimum force, this F mean. So to easily analyze these kinds of questions, uh, we need we need to make the surface, we need to make the surface as the x-axis. We need to find or we need to assign this one as our x-axis. So our y-axis would be perpendicular to the surface. So it's here. This is the y-axis. Now let's assign the figures. So the minimum force is going to the right. So it's here. Hold on. It's it's going here. It's the minimum force is here. Then the weight the weight of the object is going downward, which is here. It always is going downward. The weight is always going downward with respect to the ground. The reason why uh, it's still it is represented still as a straight force going downward. And what else? Since we are asked for the minimum force for our analysis, for this is the minimum force for our analysis, the frictional force, for us to say that the force is at minimum, or the applied force is at minimum, we need to an- uh, analyze this at the frictional force is also going to the right. So the frictional force is always also going to the right. For us to compute the minimum force needed, so here it's the F, the frictional force, and what else is missing here? So the normal force, again, the normal force is perpendicular to the surface. So if your surface is inclined, so your normal force is going here. It's perpendicular to the surface it's in. And now we're good. Now let's just rotate this on a normal uh, Cartesian plane. So here. So if our x-axis is this uh, surface, so we could make, or we could put this minimum force and frictional force here, going to the left. And then if our y-axis is perpendicular, so our normal force is here, and the weight is going here. And now, uh, here we do not still know. We still do not know what is the angle of the components of weight. And look at this one. So to get the angle, you could see here that this is a right triangle. This one, this forms a right triangle. So we have an angle of inclination of 45 degrees. This one is 45 degrees, and this is right angle. We could get this angle. So what is this angle? What is the interior angle, or what is the summation of the interior angle of a triangle? Anyone? That's some okay, thank you. So if it's 180 degrees, then what would be the angle here? Here. This is equal to, if this is 45, this is 90, and this is,
45 po.
45 din po.
thank you. So that's it. It's this one is 45 degrees. So basically, uh, the given angle of inclination, okay, hold on. Th- This, the given angle of inclination, this is always equal to this angle, uh, to the opposite angle, this one. Let's just change the color this, to this angle, okay? This angle is equal to this angle. Did you get why? Or did you understand why? Because for example, this one is 30 degrees. Just for example, 30 degrees, then this one is going to be 60 degrees. So this one is 30 degrees. So the angle here is equal to the angle with respect to y-axis here. Did you understand? Do you understand? This is always equal here. This. So if in the case you are if you are quite more confident with analyzing the components with respect to y-axis, then it would be fine. But you just need to be careful that uh, when you draw that one, for example, this 30 degrees, then this is the weight, then this is the y component of the weight, and this is the x component. If you are going to be taking the summation of forces in x-axis, so it's going to be the opposite now. It's going to be the opposite. So you are going to be using w sine 30 instead of w cosine 30, because you are more familiar with using cosine with x. But again, if you are evaluating it with respect to y, then the x component would be sine 30, though, or the weight sine 30, since it now becomes the opposite of the angle. And to be honest, it's easier. I mean, we are I personally am more familiar with this, more confident with this solution that if the given angle is at 30 degrees, then automatically the x component would be at sine instead of cosine. Because sometimes on your analysis, this is the common mistake that you are doing. If the given angle of inclination is at 30 degrees, like for example this, at 30 degrees, then you analyze summation of forces x. Most of the time, most of the students use uh, yung, mostly they use W cosine 30. But this is wrong. Again, if you are using the angle given, you need to use W sine 30 for x axis or for the x component. But since on our problem, but since on our problem, uh, but since on our problem we are having the same angle, like because the given angle is 45 degrees, then it's the answer would still be the same. It's just that your analysis would be wrong. Okay, and now let's continue. Let's go back. So here, if if we were asked for letter B, if we were asked to find the maximum force, then this means again this is the frictional force, then this is the normal force. The weight is going here 45 degrees, and the frictional force will be now opposite parallel to the surface. So this would give us the maximum needed force to move the object. So since again we know that the frictional force is the force that resists the applied force, so it is at maximum or the maximum the force is at maximum if the friction is opposing it. So here it's gonna be this. It's going here. This one is F mean. The other one is F max. So yeah, so that's it. This is our diagram. And then we can now solve for uh s- okay. So for our solution, letter A, it's still the same. Let's analyze the forces at x-axis. So at letter A, the forces at x-axis going right is positive, so it's the minimum force plus the coefficient, or sorry, the frictional force minus weight cosine 45 equals 0. So the minimum force is equal to positive, the when we transpose it, weight is going to be positive, so it's weight cosine 45. Then the frictional force would be negative F. So substituting, its mass times gravity cosine 45 minus static of coil friction times the normal force. We have, and from this, we still have two unknowns. We do not have the minimum force and we still do not have the normal force. So we are going to be doing the summation of forces in y. So at y-axis, the components are the normal force going upward minus weight sine 45, the y component of weight equals 0. So the normal force is equal to weight sine 45 or equals to mass times gravity times sine 45. So given 10 kilograms, then the gravity is 9.81 meter per second squared sine 45. So what is our normal force? Kindly solve. What is the value?
Po, sir. 69.3671.
69.36.
Opo, 717523.
Okay, thank you. And now since we already have the normal force, we can substitute this here. So so that we could uh oh no, wala. Yeah, so that let's just continue here. So from the previous one, it's F mean equals uh weight cosine 45 minus mu n. So weight is 10 kilograms, 9.81 cosine 45 minus 0.5 times 69.3671. Did I remember it right? So yeah, what is our minimum force? What is the value of our minimum force needed? 34?
34.6836 po.
And yeah, that is our minimum force. Then to evaluate the maximum force, letter B, maximum force. So we need again to have the summation of forces X, which is from the second diagram, it's F max, F max, then going to the left is the frictional force, then weight is going to the left as well, it's component of X component, so it's minus weight cosine 45 equals 0, then F max equals F plus weight cosine 45, then it's mu n plus mg cosine 45. And for the summation of y, so our y components are n still minus weight sine 45 equals 0. So our uh, normal force is weight sine 45 still. And based from a previous one, we have 69.3671 Newton. So again, we already have the normal force. We can substitute it here. So uh, ma maximum force is equal to our coefficient is 0.5, normal force 69.3671 Newton, then plus 10 kilograms times 9.81 times sine, sorry, cosine 45. So what is our maximum force needed? That is our final answer. Okay. Did you get this? Do you have any questions regarding this? None?
Wala naman po.
Okay. So I just need to check and if you really understand unit unit systems. So because I think that was another section last Tuesday. They because on your on your board work that I'm gonna be giving you, uh, it really is the same, but I used English. I think I use English and an SI unit there. So I just want to ask, uh, how will you get a pound force when you are given pound mass? So, like for example, I have here a 50-pound block. Sorry, 50 pound mass block. So to have the analysis, we need to have this uh expressed in force, right? So that we could get weight. So weight equals mass times gravity. So mass is 50-pound mass times gravity of 32.2 foot per second squared, feet per second squared. This is the for Earth. So is this correct? So that you could get a pound force here. I- Is this the right solution?
Hindi po.
Why? What is missing here?
Yung
What is missing?
proportionality constant K po.
Okay, it's the proportionality constant K. But here, what is the correct answer? What is if there is a 50-pound mass, then what would be the its weight? What would be its weight in pound force?
50 pound force din po.
Yeah, that's right. It's 50 this is still 50-pound force, and as you can see, it is the same 50-pound force is equal to 50-pound mass. Does this always is this always the case? Is this always the case that the pound mass is always equal to pound force? Is this always the case? Yes? Who says otherwise? Who says no? Is this always? Yes or no? How about the others?
Saan po yun? Okay.
Again, again?
I think po, para sa akin, no po. Okay.
Okay. No? How about the others?
No din po, sir.
Okay. Sorry, I just need to attend uh to one call. Yeah. So some of you say yes, some of you said yes, some of you said no. So basically, it is both correct. Uh, in such cases, okay. If we are analyzing weight on Earth, it would always be the same. Pound force is equal to pound mass. If we are analyzing uh weights on Earth or weight on Earth. Since the correct formula to get the weight expressed in pound force, this should be expressed in slugs times the acceleration due to gravity. And since on Earth, the calculation is, for example, your 50-pound mass, we need to convert this into slugs. And the conversion is one slug is equal to 32.2 pound mass times the acceleration due to gravity, which is 32.2 as well. So we can just cancel this numbers out and this, and we are uh, left with slug feet per second squared. And this would be pound force already. The reason why it is always the same when we are analyzing weight on Earth. Okay, did you understand? It's the same when we are analyzing weight on Earth. But if we are analyzing weight on, for example, on Mars, they have a different, or Mars has a different acceleration, gravitational acceleration, so it will not be the same as well. It will not be the same uh analysis when we talk about weight on Mars. Did you get it? Did you get it? Did you understand?
Yes po.
Okay, kindly take note of that. I'm giving you hints. Kindly take note of that. Okay, it will not be the same when you analyze weight on Mars, since again you are gonna be uh first expressing the given into slugs, slug feet per second squared to get pound force. Okay, do you have any questions?
Wala naman po.
How about the others? Do you still have any questions?
Wala po, sir.
None?
Wala po.
Okay, if that's so, then I'm gonna be posting your board work on the classroom, or in the classroom rather, and you will be passing that one on our face-to-face class. So I'll be sending you the instructions as well there after our uh later on. I'll be sending you the instructions on our classroom. And then again, on it really depends on where on where you're gonna be writing that one. It really is not an issue for me. Uh, it but for as long as uh you are gonna be writing that on a short bond paper to be uniform. But it really depends on you on if you're gonna be using it on a scratch short bond paper or a clean bond paper. It really depends on you, or you could just use your manual and then uh, tear it off. It really depends on you. Okay, but uh, what I'm gonna be asking for you is that you need to use, or you need to write it in an engineering lettering format. Is it clear?
Clear po.
Okay, so last, once again, do you have any questions? Yes, Engineer de Malibot.
Sir, hindi po question pero sorry po, pero present po ako. Medyo na-late lang po ng pasok dahil po kakabalik lang po kanina ng wifi po.
Yeah, okay, noted. Thank
Thank you
you.
po.
If none, then can I request everyone yes, yeah. Uh, Kindly open your cameras for our attendance. And Engineer De Castro,
Yes po, sir.
are you using desktop or
Hindi
laptop?
po, sir. Hindi po. Naka-phone po.
Let me just see here. Uh, Engineer Miguel.
Sir, naka-laptop po.
Yes, kindly take a screenshot of all of our meet and then just send it on our uh GC for the attendance.
Okay po.
Uh, kindly count.
Uy, mag-open na kayo ng camera para kayong others. Oh, smile para makita ni Sir na masaya kayo. One, two, three. Okay na po. Teka, isa pa pala. Okay na po, Sir.
Thank you. You can leave the class na. Thank you. See you next week.